All right. Title, complementary cofunctions, and even odd functions. Typically, I would like to do all the mathematical reasoning and why this works and why it is and da-da-da-da-da-da. Because of time, I'm going to give you formulas, do problems, and then on Friday, I'll do more explaining on why those formulas are the way they are. Okay?
How about you just like explain the lesson, and then like you're recording it right now, so like we'll be slow, but maybe we could watch the rest of the lesson.
I'm just explaining the whole questions.
Complementary cofunctions. All right. Sine x, I'm going to write down secant x, and then I'm going to write down tan of x. Now you're maybe thinking, why sine, secant, and tan instead of sine, cosine, tan like we usually do? Anyone wondering that? I know I would be.
Yeah.
Okay, the reason is because we're working right now on cofunctions. What the heck is a cofunction? What's nice about cofunctions, it's exactly what it sounds like. It's a co-function. So throw co in front, no, it really is. Throw co in front of sine, and what do you get? Cosine. Ah, you get it? Cosine, parentheses, I'll fill that in later. Throw co in front of secant, and what do you get? Cosecant. Good job. And and throw co in front of tan, and you get cotangent. Good job. I'm going to explain that right now. All right. So these are not the same as reciprocal functions or inverse functions. These are cofunctions. Listening. So when I ask you what's the cofunction of, you're either going to add the word co or take off the word co. What's the cofunction of cosine? Sine. What's the cofunction of secant? Cosecant. What's the cofunction of cotangent? Tangent. All right, so you're adding co or taking off co. That's really nice. It's really easy. Do you agree? Okay. Next part is where the kids tend, listen, there was a teacher who used to call them cocos. Cocos. I don't, but you can. Co and co. All right. So listening. Here's the next part where kids mess up. Supplementary functions add up to one, or supplementary angles add up to 180. Complementary adds up to 90. Right? Yeah. All right. So if I gave you 30 and said find its complement, you would know it's 60. But what math is going on? 90 take away the angle that's given. So 90, I'm going to write as pi over 2. Take away the angle given will be its complementary. Its complement. 90, or pi over 2, take away the angle that's given will be its complement. I'm going to say that one more time. Pi over 2, take away the angle that's given will be its complement. Complementary cofunction. Complementary.
Wait, so 90 is like code name for pi over 2?
Yeah, well, not code name, it is. They're equivalent. Remember, they're...
That's a radio. That one's with the green.
All right. Okay. Guys, I am going to write one more little side note over here. You don't have to start with sine or cosine, is what, because typically this is what's going to happen. They're going to give you this on the homework, and you're going to change it. Like, I'll give you this and say, what is that equivalent to? And you would say, oh, sine of x. Cosecant, oh, secant x. Got it? Cotangent, oh, tan x. All right, the only thing is it can be written both ways. So this could be written as cosine x, and you would say, oh, sine of pi over 2 minus x. It doesn't matter which one comes first. So this would be what? Cosecant x equals secant pi over 2. I'm just changing the order, so I'm calling this one x and this one the pi over 2 minus x.
So it doesn't matter what it does?
No. As long as they're complementary co-functions, which these are. Equals tan of pi over 2 minus x. All right. Got it? We're good? I'll do more explaining on how this actually does work on Friday. Okay. Next piece we're going to write down are even odd functions. We're going to learn more about even odd functions second semester, on what's even, what's odd, and I will talk more about it on Friday. For now, we're just going to write it down. Sine of negative x, cosine of negative x and tan of negative x. I'm only writing sine, cosine, and tangent, but the same is true for its reciprocals. So this would be true for sine and cosecant. What I haven't wrote the rest of it, but the rest would be true for cosine and secant, and this would be true for tangent and cotangent. And here is what it is. Are we ready? One of these, I call it absorb the negative and kick it to the front. Cosine is the only one that absorbs the negative. The other two kick it to the front. I will do more explaining on Friday, but know for now that what is the only one that absorbs it? And which one is the one that kicks it to the front? Okay, and I'm going to just do a quick explanation why, but I'll do a better explanation on Friday. All students take calculus. Just picture this positive and this negative. Like this is positive 30 and that's negative 30. Do you agree? Yeah. Positive 45 and negative 45. What can you say about cosine in both of these quadrants? So does it matter if I'm positive 45 or negative 45?
Not necessarily.
Cosine's going to come out exactly the same.
Or using the sun at the beach.
Yes, that as well. You could think of it that way because that's something someone in my morning class said as well. But yes, does that make sense? Okay, I will do, if you didn't get that, you're like, whoa, I didn't get it. I will do a better explanation on Friday. Just kind of a brief overview. Are we good? I suppose. All right, verify. Verify is prove. Your pick a side and you work. Number 1, tan of pi over 2 minus x secant x equals cosecant x. Okay. Pick a side.
Left.
Left. That's a good choice. Also, what else should be screaming at you here is this guy right here. Change me, change me. He should be like screaming at you. So if you see that, that's the side you should pick. You're not going to typically have that on both sides. All right. So without even looking up here, what's tangents? Cofunction. Cotangent. And like I said, you're just going to change the pi over 2 minus x to just x. Cotangent x. How easy is that? Times secant x. Now, any thoughts and suggestions on how to get this to this? Change everything to sine and cosine. While you do that, I'm going to take a step back. Would anybody like me to repeat what I just did? We're good? We use this one. We use this one right here. Right here. Tan of pi over 2 minus x is equal to cotangent x. Okay?
Basically,
Cosine x over sine x times 1 over cosine x. Does it work? What's 1 over sine? Cosecant x equals cosecant x. Awesome. Make sense? Good. Okay, I'm going to move over. We're good? We're ready? No. Number 2. 1 plus sine of y. That's not sing. I had a messy y in my morning class. 1 plus sine of y. And 1 plus sine of negative y. Like that in parentheses. Equals cosine squared y. Which side should we pick? Left. All right. What should be screaming at you on this one? Change me, change me. This right here? Okay, so thinking what we said without looking over, is that the one that absorbs or kicks to the front? Kicks it to the front. Cosine's the only one that absorbs. Cosine and its reciprocal. 1 plus sine of y, that's a y, and then 1 plus sine or minus if it kicks it to the front? Okay. Any thoughts on what to do next? Foiling is correct. 1 times 1 is?
1.
Minus,
It would be nothing.
which will be nothing. He is correct. He's working ahead. This step I'm showing, I most likely will not really show again. I'm going to skip that step because I'm assuming everybody can do that in their head. These are called conjugates, and when I multiply conjugates, what always happens to the middle terms?
They cross out.
They cross out, and what am I left with? 1 minus sine squared? That's still not quite done, but is that an easy step? What is 1 minus sine squared?
Cos squared y.
Cosine squared y, and is that what we're trying to get?
Wait, so there's a 1 and then minus sine y, sine squared y. Okay,
Yep,
yeah.
we're good?
Yeah.
Okay, number
Oh, 3.
3. This isn't a evaluate. This is not a verify. Sine squared 35 degrees plus sine squared 55 degrees. Is this one of our identities?
No.
Not quite. There's 2 things that are wrong. Can anybody tell me the 2 things that are wrong?
Degrees.
The degrees are not the same, and these are the same, the sine and sine. Okay. Now, kids ask, well, how do I know? You can get the practice. On tonight's assignment, you know these are complementary functions or even odd. And it's not one of the negative, like sine of negative y, so it must be a complementary cofunction. Pick one. It doesn't matter which one. I'm picking the first one, and this comes up again on your final as well. Think about it. What is sine squared's complementary cofunction? Sine becomes cosine. And 35, what do I do with 35 to subtract it from? 90. Pi over 2 is fine, but why am I picking 90? Because it's a degree.
It's a degree to.
Degree to a degree. It's easier. So what is 90 minus 35? I'm hoping it is.
Don't you say squared?
This right here is squared. Thank you very much. All right, cosine squared of what? 90 minus 35 is 55 plus sine squared. Oh, what does that one of our identities? It equals 1. Very interesting.
So how do we know when to use the cofunction?
Let me show you one last one really quick, and then I'll answer that question. 1 over cosecant x. I know. But I want to show it to you because you have not seen one like this yet. Cosecant x minus cotangent x. Do you see how these are pretty much almost the same? Yes? When you see this on the test, know that it is a conjugate problem. A lot of kids struggle. They try to make it harder than what it is. It doesn't matter which side you pick. I'm going to pick the one that's in a fraction form because it's easier to see. You take it and you multiply top and bottom by the conjugate. You learned conjugate last year. Conjugate of cosecant x plus cotangent is the minus. Cosecant x minus cotangent x. And I know the bell's going to ring on me, so I'm going to try to rush. What's nice about the numerator is it just stays. Do you agree? Cosecant x minus cotangent x. Here's I'm going to use my shortcut. Conjugate, what happens to the middle terms? Cancel. Cosecant times cosecant? Squared. Middle cancel. Minus what?
Minus squared.
Cotangent squared. Can you guys look at your identity page and see what cosecant minus cotangent is? Or cosecant squared?
That's 1.
Is it 1? So we're left with cosecant x minus cotangent x, and is that what we're trying to prove? Oh, right on time.
Good stuff, man.
All right, thank you. Okay, you guys have your assignment sheets. Darren asked me a question.